All right, good morning, everybody. Welcome back to another live stream from Scalar Learning. Today, I'm doing something different that I have never done before. So I'm just doing a quick sound check. Looks like we're good on sound. I'm doing something different, and I'm doing something that I haven't done before, but I'm really excited about. And what that is I'm doing a challenge with ALEKS. So before I jump in, let me explain what ALEKS is if you don't know. ALEKS is an online math program. It's a math curriculum with for pre-algebra, 6th grade math, 5th grade math, going up through high school levels. And it's actually, in my opinion, one of the best math programs, if not the best math program available on the market to supplement in-class instruction, because it allows for students to self-pace. It has mechanisms in place to test students once they've learned a certain number of topics in the form of something called knowledge checks. And if you then need more practice, it sends you back to redo the topics. I mean, it's really, really cool. We use it at my school where I teach, and the students use it there to supplement everything they learn with the in-class curriculum. And I just find it to be incredibly effective. The reason why I wanted to do what I'm about to do is because I wanted to create explanation videos for all the topics that exist. Now, there are amazing written explanations within the program, and I believe they now have video explanations, but I wanted to teach it my way and have a video resource available for everybody who's doing their pre-algebra pi right now in ALEKS. And I'm trying to do it all in one sitting, in one continuous live stream. We'll see how it goes. I don't know. I have an estimate for how long this will take. The thing is, I'm not just going through all the topics, and there's 630 to complete, but I'm actually trying to explain. So the format is going to be that I'm going to explain one question out of each topic, and the next 2 or 3 that I have to complete, I'm just going to do them as fast as I can, because I think this is going to take me over 10 hours. And I have only until around 4 o'clock p.m. So that's about 9 hours of total available live streaming time. Honestly, I don't even know if I can last that long, but we're going to give it a shot, and I'm going to try and make a big dent and see what happens. So this is my ALEKS challenge to get through this pre-algebra pi. I know it's early on the West Coast. On the East Coast, maybe you have the day off and you're going to follow along, maybe jump in and then jump off and then come back later to see where I'm at. But without further ado, let's do it. So I'm going to quickly explain what ALEKS is. So here you can see is the ALEKS interface. On ALEKS, you have your path, whatever math class you're in, whether it's pre-algebra, like I said, or algebra 1 or geometry. It has all these topics. So if you look over here, these are the topics that I have. So I have whole numbers and integers, fractions, decimals, ratios, proportions, and measurement, percents, equations and inequalities, graphs, functions, and sequences, right? So you can see all of these different these are kind of like the bigger units, and then within them, they tell you the amount of topics, 51, 53, 34. Now, every topic you're going to have 2 to 3 questions that you need to answer correctly in a row before you can move on to the next, and you kind of get it checked off and you can move on to the next topic. So it's quite a lot of practice problems that are going to need to be completed. And this is the famous ALEKS pi. So each one of these pie slices relates to one of these topics, as you can see. And so as topics start getting knocked off, that pie will be complete. So again, the goal is by the end of today to have this pie completely filled out. Now, like I said, I think based on my calculations, I don't think I'll have enough time. I think it's going to be more along the lines of 14 or 15 hours that are needed to do it. But we'll see how far we get, and we'll take it from there. Without further ado, let's begin. So again, class progress 0 of 630. Here's my whiteboard where you're going to see all my work. Let me click this. All right, let's begin. Oops. All right, so they're giving us a little tutorial. This is your learning page. Cool, got it. Now, everything will have explanations like this. It'll kind of explain the different processes that you'll need to know to solve these questions. I'm never going to really look at those or talk about those. I'm just going to dive in, and you're going to learn, hopefully, by watching me do an example. And let's begin. All right. Topic number 1, straight up subtraction. So this, I think people should be familiar. We're doing 479 minus 352. We're going to set it up like this. I'm going to just subtract down. 9 minus 2 is 7. 7 minus 5 is 2. 4 minus 3 is 1. And that's it. Our answer is 127. Okay, boom. The next two I'm just going to do really fast. So this is 236. And 823. Yes. Boom. Mental math. All right, cool. Topic 1 done. All right. I got that. Thank you. Yeah, this, so they're just kind of still giving me a tutorial because this is the first time I'm using this on this account. All right. Let's get rid of this. All right, addition. So the way we handle this, again, we just set it up just like they have it written there. And I'm going to add one at a time. 1 plus 7 is 8. 9 plus 7 is 16. And we've got our answer of 168. All right, boom. Let's move on to the next one. I'm going to switch to this whiteboard. I like this whiteboard better. All right, so then I'm going to do these in my head. This is 190. And this is 57. Oops, 120, 135. All right. Two topics done. I'm on a learning streak. Adding 3-digit numbers with regrouping. So this is the same idea. We're just going to be carrying over. So let's look at this first one here. Oops, 291 plus 296. And here's how regrouping works. First, we add the same way as the last problem. 1 plus 6 is 7. 9 plus 9 is 18. So we place an 8 like that and carry the 1 from the tens group into the next group. And then we have 1 plus 2, which is 5. And there's our answer, 587. All right. Next two, I'm going to just do these quickly in my head. 722. Okay, and then we have 317. All right, cool. Continue my path. Let's keep going. Subtraction of 2-digit numbers with regrouping. So let's try this. So we got 42 minus 27. Now we cannot do 2 minus 7. We need to borrow a 10 from the 4. So that 4 drops down to a 3. And we bring that little 10 right there. So now it's no longer a 2, but it's a 12. And we got 12 minus 7, which is 5. And then 3 minus 2, which is 1. And that gives us 15. All right, 96 minus 77, this is just 19. And 93 minus 50, that's 54, I believe. All right, cool. Let's move on. Let's begin. All right, so rewrite as a multiplication sentence. If you look at this, it's 7 plus 7 plus 7. How many 7s is that? It's 3 7s. So that's all they want you to do is write this as a multiplication problem. Now, how many 2s are here? 1, 2, 3, 4, 5, 6. And let's do the next one, which is 5 times 3. Boom. All right, keep going. Adding 3 or 4 numbers with 2 digits. Here we go. So we've got 4 numbers, 82, 54, 37, and 41. And we're going to add all of these guys up. So we're just going to add down the line here. So we got 2 plus 4 is 6. 6 plus 7 is 13. Plus 1 is 14. So I'm going to put that 1's digit here and carry the 10's digit, which is just a 10 or 1. And then now we're going to add these up. 1 plus 8 is 9. Plus 5 is 14. Plus 3 is 17. Plus 4 is 21. So if I've done that correctly, it's 214. Boom, excellent. So I'm going to do these in my head very quickly. 46, 96, 103. And one more. We've got 20, 30, 50, 70, 160, 173. I believe that's right. Let's see, hopefully. Otherwise, I'll do it again. All right, cool. Excellent. Continue my path. Multiplying 2-digit and 1-digit numbers. Let's begin. So again, we're going to set it up just like they've got it there. 3 times 57. First 3 times 7 is 21. So we put that ones digit here, but we carry the tens digit. We're going to tuck that away, use that later. Then we do 3 times 5, which is 15. And then we add this 2 to the 15, which is 17. And we get 171. All right, let's go on to the next one. Now we have 7 times 8, 48. So I'm just going to do this mentally. 280 plus 56 is 336. All right, and then the next one is 8 times 46, which is 48 plus 320, which is 368. All right, let's begin. We're adding 3 numbers, so let's look at it this way. 285 plus 81 plus 1655. Now, it's very important as we watch this, you need to have everything lined up, all the unit digits, all the tens digits, hundreds digits, and thousands digits. And the way we're going to add is just like any other addition problem. 5 plus 1 plus 5 is 11. Put down the ones, carry the tens. 1 plus 8 is 9, plus 8 is 17, plus 5 is 22, carry the 2, 4, and then a 10, carry the 1, and a 2. So the answer is 2021. All right, let's keep going. And now I'm going to do the next 2 really fast. I think I can do this mentally. Ooh, no, this is actually kind of hard, so I will write it out. 28, 6555, 9, 14, carry the 11, 16, carry the 1, 11, 6164. All right, and last but not least, number 3. 481 3528 65. 13 14, carry the 1, 10 11, 17, carry the 1, 10, carry the 1, 4. 4074. All right, continue. Here we go. Now we're talking about ordering numbers from least to greatest. So let's order these large numbers. Now this we can look, and I mean this is basically just straight up the number with the most digits, since they're all whole numbers, is going to be the biggest. And the biggest number is going to go over here. Remember, the open side always eats the largest number. So you see this one, this number is greater than this number is greater than this number is greater than this number. It's kind of like pointing down. It's pointing to the lowest. So we're just going to drag the biggest one here. This one here, this one here, and this one here. Now this is clearly the biggest. This is 953,000. This is only 94,628. So it's in the tens of thousands. These two are both in the thousands, but this is 5,000 versus 2,000, almost 6,000. And that's it. All right, these next 2 I'm going to do very quickly. Next. All right, continue the path. Here we go. Let's begin. So we got 440 minus 79. So again, we got to borrow because we can't do 0 minus 9. This number needs to be bigger on top. So we're going to borrow from the 4. 4 is going to turn into a 3, and we get a 10. Now it's 10 minus 9, which is 1. But now again, the 3 is too small to subtract the 7. So he borrows from the 4 over here. The 4 becomes a 3. This becomes 13. 13 minus 7 is 6. And then 3 minus nothing is 3. So our answer is 361. All right, excellent. Next two I'm going to do in my head. It's a little tough. Let's see, 200, 190, 189, I think it is, right? 9, yeah, let's go for it. Yes, all right, cool. And then next, oh, this one's not so bad. 293. All right. Multiplying multi-digit and one-digit numbers. Here we go. 8 times 459. 8 times 9 is 72, carry the 7. 8 times 5 is 40, and we add that 7, so it's 47, carry the 4. You see I'm always carrying that tens digit. And now we do 8 times 4, which is 32, plus that 4 on top, which is 36. And we get 3672. All right. These next two, I don't think I can do in my head. I can do this in my head. 6,360, 9,672, 9,672. Right? Yes. All right, let's see if I can do the next one mentally. 324, 26, 10, 26, 19. 2619. Let's see if that's right. Come on. Yeah. Sweet. All right, continue my path. Here we go. All right, subtraction with multiple grouping. We got 1, 5, 3, 6 minus 8, 6, 2, and we're subtracting. Let's do it. 6 minus 2 is 4. Again, we can't do 3 minus 6, so we got to borrow from the 5. This becomes 4. This gets a 10, so now it's 13 minus 6, which is 7. And then the 4 can't subtract the 8. We need to borrow from that 1. So this becomes 14 minus 8, which is 6. And then that 0 minus 0 is nothing. So we got 6, 7, 4. Excellent. All right, I wrote that down correctly. Yes. Okay, let's go to the next one. I think I can do this in my... No, this is a little tougher. I'm going to just write it out and make sure I get it right. 655333086. We got 4. 13 minus 6 is 7. 14 minus 8 is 6. And 3, 4, 6, 7. All right, last one. 3055 minus 2937. Subtract. 15 minus 7 is 8. 1, 2, 10, 118. All right, excellent, excellent. 12 topics, amazing. So see, now we are cooking. It always has these fun little messages when you get on a learning streak. Okay. All right, multiplication of large numbers. 21 times 42, let's do it like this. First, the 1 goes down the line, and then we come back to the 2. So 1 times 2 is 2. 1 times 4 is 4. Now we go to the next one, and since this is in the tens, we add a 0. 2 times 2 is 4. 2 times 4 is 8. And then we add it. 2, 8. 4 plus 4 is 8. And then 8 is 882. So see, when we get to this stage, now we're adding down. And our final answer is 882. Moving on. Oh, that's the same. I think that's the same one. 21 times 42. Let's double check. 42, 0, 4, 8. Yeah, 882. What? That's the same one again. Strange. All right. Continue. Division of whole numbers given in fraction. Okay, so this they want us to rewrite as a whole number. Well, any number divided by itself, 11 over 11, is simply 1. But this is a, otherwise, normally this is, we take the numerator and divide it by the denominator. But in this case, it's just 11 divided by 11, which is simply 1. Okay, so again, when we have fractions, it's really just a division problem. So this is in fact the same as 16 divided by 2. And what is 16 divided by 2? Is simply 8. All right, next. This is 7. 49 divided by 7 is 7. All right, 14 topics, 14 out of 630, not so bad. Subtraction and regrouping with zeros. Here we go. So we got 4304 minus 1168. Let's begin. Can't do 4 minus 8. Can't do 0 minus, can't borrow from the 0, got to borrow from the 3. So this becomes a 2. This becomes a 10, and then we borrow from that 10, turn into a 9. Now we got 14. So now we subtract down. 14 minus 8 is 6. 9 minus 6 is 3. 2 minus 1 is 1. 4 minus 1 is 3. Final answer is 3136. All right. Next we have 9045 minus 764. Subtract, we got 1, 8, 10, 9, 14 is 8, and then 2, 8, 8, 2, 8, 1. And 1067 minus 793. Can I do this in my head? 774, 274. All right. I think that's right. All right, cool. Whole number division, 2-digit by 2 digits. All right, let's see what we got here. So we got 84 divided by 4, and I believe these are going to be division problems with no remainder. So you can think about it, just we're going to count by 14s and see how many 14s go into 84. I'm going to estimate, this is something where you can kind of get an idea first and then just do the multiplication. But it sure seems to me like 6 is the viable answer because 6 times 4 also ends in a 4. So I'm going to do 6 times 14 and test it out. 6 times 4 is 24. Carry the 2. 6 times 1 is 6 plus 2 is 8. And that is correct. All right. Sixteen topics. Division with regrouping. One-digit divisor. See what we got. All right, we got 81. Whoops, 81 divided by 3. So let's go. 3 goes into, we're going to follow this process. Some people call it daddy, mommy, sister, brother. We divide first, and we say 3 goes into 8. How many times? It goes in 2 times. Then we multiply the 2 times the 3, and we get 6. Subtract. 8 minus 6 is 2, and then that's after the subtraction. We bring down the 1, and then 3 goes into 21. 7 times. Multiply. 7 times 3 is 21. Subtract, and we get 0, or a remainder of 0. So it's exactly 27. All right, let's keep going. These I'm going to do in my head. So this is 14. And this one is 39. All right, here we go. Now we got some word problems. All right. The key with the problem like this, you got to really figure out what are they asking and how do we take care of this. So we're saying Dan has 578. He gave 153 away. How many does he have left? If you give away, you're losing. This is a subtraction problem. And so we just set up our subtraction problem. 578 minus 153, which is 8 minus 3 is 5. 7 minus 5 is 2. 5 minus 1 is 4. And our answer is 425 marbles. All right, here we go. There were 517 coins in a fountain. 257 more were thrown in. This is addition. 257. 1, 7, 7, 7, 7, 4. Okay, together, so we've got 769. All right, word problem with multiplication or division. A sports tournament has 5 teams. Each team has 40 players. How many total players are there? This is a multiplication problem. We've got 5 teams, each with 40 players. So we just do a multiplication problem. 5 times 0 is 0. 5 times 4 is 20. Therefore, we got 200 players in total. All right, excellent. Next. Here we go. Maria has a bookcase with 2 shelves. Each shelf has 14 books. How many books are in the bookcase? This is, again, multiplication. So 2 times 14. Each shelf has 14 books. This is 8 and 2, 28. There are 4 piles of paper on a desk. Each pile is the same number of papers. There are 40 papers in all on the desk. How many papers are in each pile? This is division. So this is actually 40 divided by 4, divided by the number of piles there are. So each pile has 10 papers. All right, division with regrouping. Here we go, 714 divided by 3. 3 goes into 7. How many times? 2 times. So we place that 2 on top of the 7. Multiply down. 2 times 3 is 6. And then we subtract. 7 minus 6 is 1. Bring down the 1. 3 goes into 11 3 times. 3 times 3 is 9. And then we subtract, and we've got a 2. And now we bring down the 4. 3 goes into 24 8 times. Multiply down like this. 8 times 3 is 24. Subtract, and we get a nice remainder of 0. So the answer is 238. All right, here we go. Next. All right, I'm going to do this in my head. 1677, right? Let me think. 32, 33, I think that's right. Come on. All right, sweet. This is 122. All right, cool. 20 topics. Amazing. So 20 out of 630. So still got 610 topics to go. Let's keep going. Introduction to non-unit fractions. The figure is cut into 8 equal pieces. What fraction of the figure is shaded dark? Well, to do this, we got to count the total. The total is always going to be the denominator. So we count the total number of pieces, which is 1, 2, 3, 4, 5, 6, 7, 8. And then we just put on top the number that is shaded. 1, 2, 3, 4, 5, 6. And I don't know if they want us to put it into simplest form, but if we do, we could just see if we can divide the top and bottom by the same number. We can divide both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And so we can say 3/4 is shaded. All right, this is 3/4. And now we've got 4/5. All right, we get algebraic expressions. Okay, evaluating an algebraic expression. Find the value of a minus 9 when a equals 12. This is just a plug and chug operation, as I call it. So we simply replace that a with the value of 12. So a minus 9 is simply 12 minus 9, which is 3. All right, again, 18 minus 4 is 14. $26. All right. If you saw in the comment down there, it was pretty funny. It said, breathtaking, Josefa, in terms of the progress so far. We're making progress. This is going to take a long time. So settle in for a long day of math. Okay, here we go. Introduction to inequalities. Now we're figuring out which one of these to use. Remember, the alligator mouth always opens, always eats the bigger number. So if I had a 5 and a 4, this should be facing the 5 because the 5 is larger. So we do the same thing here. The 59 is greater, so the open alligator eats the 59. 250, we have an alligator eating the 250 because it's bigger than 16. And then here we have 496 getting eaten. Same deal here. All right, now we're getting along to the next one. The next topic here, we've got introduction to parentheses. Just taught this actually to my 3rd grade group. Parentheses. Wish it would load a little faster. Okay, let's see what we got here. Okay, 5 minus 6 divided by 3. Well, what do the parentheses do? The parentheses tell us, and in fact here, the parentheses actually don't even matter, because by order of operations, we do division first. But the parentheses tell us what to do first, and since the division is grouped in the parentheses, we do that first. So we know that 6 minus 3 is 2. And then we evaluate the subtraction. 5 minus 2 is 3. All right, let's do the next 2. Here we go, 5 plus 6. 5 plus 6 is 11. Right, again, the parentheses are telling us what to do first, so we prioritize that multiplication. Now we do the subtraction first. 4 divided by 2 is, is 2. All right. I'm going to launch my Instagram live stream so people in my Instagram audience can also watch this as well. Let's see here. All right, let's keep it going. So, for Instagram folks, if you're just tuning in, this is a live stream where I am basically doing a YouTube live stream right now on a program called ALEKS, where I'm tackling all these math problems one after the other. So if you want to watch along, you want to actually see what I'm doing with these math problems, go to my YouTube channel, go to YouTube, search for Scalar Learning, and you can follow along on YouTube. What's up, Jake? Yeah, I see you. So go ahead and jump on my YouTube channel and you can watch me actually go through the pre-algebra pi. All right, so now we're continuing to the next topic. All right, here we go. Evaluating an algebraic expression. All right, here we go. So we've got 9 times p when p equals 6. So this is the same thing. Again, we're just plugging in the 6 for the p. So we replace that p with a 6. So that becomes 9 times 6, which is, of course, 54. And that's it. All right. Like I said, I wish this ALEKS program would go a little bit more quickly, but it is what it is. All right, question number 2. I'm gonna do these next 2 really quickly. We have got, and again, for all you guys joining and watching right now, hey, how's it going? Thank you for joining. Make sure to go to my YouTube channel so you can actually see what I'm doing. And if you go to YouTube and you search for Scalar Learning, you will find it, and you will find the live stream. So I'm doing a YouTube live stream right now. All right, let's do the next one here. And lastly, we are going to get one more problem here eventually. Let me just show you guys what I'm doing here, right? You can see on my computer, I've got ALEKS going right there. So that's what I'm doing. I'm working through this online math program. I'm kind of going through an entire pre-algebra curriculum. All right, then we got this one is 5. All right, thank you guys for joining on Instagram. Like I said before, I'm actually doing a live stream on my YouTube channel that I want you to check out. So go to YouTube, search for Scalar Learning, and you can follow along. I'm basically trying to teach over the next 8 or 9 hours entire pre-algebra curriculum. Whoops. I'm trying to teach the entire pre-algebra curriculum. So it's going to take a long time, but I'm going straight. But you got to go on my YouTube channel if you want to follow along. Go to YouTube and search for Scalar Learning. All right, here we go. Next. Multiplication of large numbers. All right, 74. Oops, 74 times 5, 76. 4 times 6. So we're going to handle the 4, go down the line to 6, 7, and 5, and then we'll jump down to the 7. So 4 times 6 is 24, carry a 2. 4 times 7 is 28, plus 2 is 30. Carry the 3. 4 times 5 is 20, plus the 3 is 23. Next line, we start with a 0. Sometimes people put out a smiley face to know that that's just the starting 0. Then we have 7 times 6, which is 42. Carry the 4. 7 times 7 is 49, plus 4 is 53. Carry the 5, and 7 times 5 is 35, plus 5 is 40. And now let's add it together. 4, 2, 6, 2, 4. 4, 2, 6, 2, oops, 6, 2, 4. All right. Alrighty, Dottie, thank you so much for subscribing to my YouTube channel. I so appreciate that. And I hope you're enjoying the live stream. And I hope you're learning from it. So let me know what you think. And you can message me or throw comments up here if you have any questions or you want me to review anything or explain anything as I'm going along. All right, now next, let's go to 67 times 303. 7 times 3 is 21. 2, 3 is 21. 0. So again, I'm doing this one faster because I've already explained the first one. 18, 1, 10, 3, and 2, 2, 1. 2, 1, 3, 0, 1. See what we got. Uh-oh, made a mistake. Whoops. 7 times 3 is 21. Carry the 21. 21, 18. 18, 1, 0, 3. Oh, that's a 0. 20,000. My bad. All right. Oops, now I got sent back. See, now every time you get a question wrong in ALEKS, if I have that streak going, usually in ALEKS where I'm getting one question right and then I get the next question right, you only have to do 3 in a row. But now because I've made a mistake, it sent me back, so now I'm going to have to do an additional 3. And that's the thing. That's actually a good thing. I know sometimes students get frustrated when that happens, but it's actually great because it ensures that you've got a good grasp of the material before you move on. 28, 30, 6, 9, 6, 3. So 3, 6, 9, 6. I just did that one really quickly just to try and get to the next topic. Is that right? 3, 6, 9, 6. All right, good. And I think I have to get one more and then I'm done. And now I love to do math mentally. I can tell you though that these problems are too big for me to do in my head. I don't think I'd be able to pull that off. So we got 46 times 286. We got 36, 48, 51, 5, 12, 17, 0, 24. Carry the 2, 32, 34. Carry the 3, 8, 11. We got 6, 5, 1. Carry the 1, 3, 1. 13,156. think that's right. Let's see, let's see. Yes. All right. That was a brutal topic. Let's move on to the next topic. Again, for you guys watching on Instagram, if you want to see what I'm actually doing, go to my YouTube channel, go to YouTube and search for Scalar Learning, and you can watch everything there and see the actual problems that I'm solving. You can go through, and today I'm covering the entire pre-algebra curriculum, or as much as I can fit in over the next 8, 9, 10 hours, or maybe less if this becomes a little bit too intense for me. But tune in, and if you ALEKS is part of your curriculum, the math program ALEKS, then this is going to be a great live stream for you to watch. Okay. Order of operations. This is all about PEMDAS. PEMDAS. Here we go. PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. I always put these on the same level, multiplication, division, addition, subtraction, because these are actually, multiplication isn't before division. So let's look at this equation here. We have 25 minus 5 times 4. Now, we don't have any parentheses, we don't have any exponents, right? So we don't have to worry about that. But then the first thing, we have a multiplication. That means we handle this one first, and then we handle the subtraction second. So we do 5 times 4 first, which is 20, and then 25 minus 20, which is 5. All right, let's check this next one out. All right, sweet. Here we go. Next problem, order of operations. So the next one I'm going to do mentally, and I'm just going to talk it through and explain. All right, 64 divided by 8. We do that first, which is just 8, and then 8 plus 64 is 72. All right, cool. Here we go. Next problem. Next problem. Let's jump into this one, if it loads. All right. So I wish it would load a little faster. All right, there we go. So we do that multiplication first. 6 times 6 is 36, plus 4 is 40. Done. Whoops. No explanation. No explanation. No. I didn't mean to hit that. So when you hit an explanation in ALEKS, it actually counts it as if you got the question incorrect. And it gives you a really great written explanation. So let's see, it's going really slow. So yeah, this is what happened. It gave us an explanation of how to tackle this problem step by step, and there it gives us the answer. But the problem is now, when you click explanation, you lose that streak. So I'm going to have to do 2 more problems instead of just doing one and being done with the topic. All right, here we go. So 28, so it's 28 minus 4, which is 24. All right, and last problem, here we go. All right, this is 30 minus 4 is 26. Sweet. All right, plotting integers on a number line. I am just waiting for this to load right now, guys. So sorry for the slowness. So this is all about plotting numbers on a number line. Now, all you got to do is just look. Each one of these hash marks is one number, is one space. So if we want -4, it's going to be right here. Look, -1, 2, 3, 4. So there's -4. We want to, oops, no calculator. We want to use this dot function. So here's -4. And then it wants +8. Here's 5, 6, 7, 8. And then we want -6, excuse me. Here's -5. Here's -6. And that's it. All right, cool. Again, if you guys are watching on Instagram and you want to see actually what I'm doing, the problems I'm solving, go to my YouTube channel. Go to YouTube, search for Scalar Learning, and you can follow along there with the live stream that's going on now. And we've been live on YouTube for almost an hour and counting. All right, so now we got to plot 7, 1, and -12. First, I'm going to do 7. Then here's 1, and here is -12. Oh, I did 8. Oh, I made a mistake. That was, so I did, see, I went too quickly because this is 5, 6, 7. Here's 7, and I put it on 8. Ah, shoot. Now I'm going to have to redo that one. All right, there's 7. All right, let's go again. Oh man, I think what's happening is because I'm live streaming, it's really keep making it slower. What's up, math memes? So we've got again, if you want to see what I'm actually doing, I'm solving math problems through ALEKS, which is an online math curriculum, but I'm doing it on my YouTube channel. So if you actually want to see the problems and follow along, go to YouTube and search for Scalar Learning, and you'll be able to watch it there. All right, waiting. After this, I'll show you guys too. We'll do a quick check to see where we're at in terms of the pi. It's really cool how this program tracks your progress. Okay, -9, -11. We want -3, and we want +8. Why is there a dot there? I don't want this dot. So -11, -3, and +8. All right. Continue. 28 topics. All right, so there we are. We're at 28 topics, almost 30 topics, and then at 30, we'll have 600 still to go. My original estimate was I was thinking it would take about 1 minute maybe to do each topic. I was optimistic that that would be the case. As you can see, and we still haven't even gotten to some of the more advanced topics, I was totally off with that 1 minute estimate. It's seeming more like around at least 2 minutes, and so it's not realistic that I'm going to finish all the topics today, but I'll do my best. All right. Conversions involving division and fraction. So fill in each blank with the whole number. So we're trying to figure out what this value is. So what over 8 equals 1? Well, in this case, the only number divided, because this is again a division problem, the only number divided by 8 that equals 1 is the number itself of 8. So this has to be 8. And then this question is just asking what is essentially 6 divided by 1, 6 over 1, and that's simply 6. All right, next question here. Next question. Hey, what's up? Hello, bye. Bye. Okay, here we go. Same thing. What over 1 is 4? It's simply 4. 2 over 2 is 1. All right, and next conversions, one more conversion involving division in fractions. What over 7 is 1? Simply 7, and this is simply 5. It's interesting going through the program myself because I've heard frustrations sometimes. I mean, like I said, I think this is a phenomenal program, but I know I hear frustrations about the loading time sometimes related to ALEKS when they're in class, but I'm always just assisting. I'm never actually chugging along going through it like I'm doing now, and I see that. I get that. You enter it and you're kind of waiting. Especially it can be frustrating if you want to make fast progress like I'm trying to do in a condensed amount of period of time. All right, let's simplify. Simplification. So we got 7/14 in its simplest form. What do we do when we simplify fractions? We see if both of these can be divided by the same number. Well, these both can in fact be divided by 7. Therefore, this fraction is equivalent to 7 divided by 7, which is 1. 14 divided by 7, which is 2. And therefore, it's 1/2. Okay. One half. This is great for, this is why we want to learn greatest common factors, because we use greatest common factors to simplify fractions. Right there, the greatest common factor of 7 and 14 was in fact 7, and that's why we chose that number to divide those guys. 6 over 9 becomes 2 over 3. All right, waiting and waiting. And then next, let's see what this guy is. Six over 8 is just 3 over 4. Just like that. Hey, what's up, Orlando? Sorry, I didn't see your comments there. Oh, I see Fang Jester. Sorry, I missed these comments. Said you're learning a bunch. That's so great. I'm really glad. And we're just going to keep it going. All right, let's continue the path. 2 topics. Wait a minute. Oh, yeah, 2 topic streak because I got something wrong, I think, before. Actually, I don't know. I don't know why that's... yeah, so I think it calculates and tabulates the streaks of correct answers, and I've actually made some mistakes. So, hey, guys, I see more Instagram people are watching on the live feed there. Really, if you want to learn and see what's going on, you got to go to my YouTube channel. Go to YouTube, search for Scalar Learning, and you can watch the live stream where you can actually see the problems that I'm solving. And that will be much more informative and instructional and helpful than watching me on Instagram. But you're welcome to watch here as well and hear me describe the problems that I'm solving. Okay, describing an increasing or decreasing, what is this? I can't read this. Describing an increasing or decreasing pattern from a table of values. So Manuel drove to and from work each day last week. The table gives the amount of gas in his tank after each day. So as you can see, it's clearly going down as he drives more, which makes sense. With each additional day, the amount in the tank clearly decreases. And how much is it decreasing by? Well, it's decreasing consistently by 3 gallons, 16 to 13 to 10, etc. And that's that. All right, here we go. Next. This is interesting. And I wonder myself, I wonder why maybe it's going a little bit slower today in particular, because maybe a lot of kids are spending time doing their ALEKS homework before school comes back tomorrow. All right, so this is clearly increasing by $6 each time. All right, 71, 77. It's jumping each incremental year by $6. All right. All right, this is clearly decreasing by 5 every time, right? 40, 35. All right, continue. Word problem with multiplication and addition, I'm guessing. Yeah, or subtraction of whole numbers. Okay. So again, just using these same principles, but in a word problem format. This is really getting crazy. I am not sure why this is taking so long. All right, here we go. Elsa bought 7 cans of cola to a party. Deandra brought 17 packs of cola, and each pack had 8 cans. How many cans did they bring in all? So each one has, so the first one brought 7 times 8, plus Deandra brought 17 times 8. Now what we can do to make this a little easier, we can actually factor. This is a trick that we can use because both of these are multiplied by 8. So it's really 8 times, and then we just add these two guys within parentheses. 8 times 7 plus 17. This helps us do it mentally if we want to do it that way. 7 plus 17 is 24. And then 8 times 24, simply 8 times 20 is 160, plus 8 times 4 is 32. So 160 plus 32 is 192. There we go. Oh, did I do that wrong? 7 cans. Oh, I read this wrong. I see it now. Okay, sorry, she didn't bring 7 packs. She just brought 7 cans. She brought 17 packs with 8 cans each. So this is 7 cans plus 8 times 17. And 8 times 17 is 80 plus 56, which is 136. And then 7 plus 136 equals 143. There we go. All right, just waiting for this to load. Here we go. All right, cool. So that's 143. Let's go on to the next. Two part-time jobs, landscaping, earns 21 a day, and then tutoring in the afternoon earns 32. How much does he earn in 9 days? Okay, so he's basically making $21 in the morning and $32 in the evening. And then this is multiplied by 9 over 9 days. So I'm going to add this first, and we get 9 times 21 plus 32 is 53. 9 times 53 is, I do it mentally like this, 9 times 3 is 27, 9 times 50 is 450. So 450 plus 27 is 477. All right, here we go. Next one. The Drama Club ordered 19 pizzas. Each pizza had 8 slices. So that's 8 times 19, which is 80 plus 72, which is 152. And then the 8 7, so you take 7 away, and it's 145. 145 slices left. All right, let's see. There we go. There we go. Hey there, yes. So what I'm talking about for Instagram, somebody just asked what I'm talking about. I'm talking about math. If you want to understand what I'm doing, you got to go to my YouTube channel. So go to YouTube, search for Scalar Learning, and you can see the live stream there, and you can see what the problems I'm actually working on. They'll be on the screen. You can see what I'm writing. As I'm just talking, I'm sure it's going to be difficult to follow along, but I wanted to reach out to everybody on Instagram to let you guys know that that's what's happening on my YouTube channel. All right, addition of decimals. Vertically aligned. All right, just waiting for this to load here. As soon as we've got the decimal problem loaded, I'll tackle it. Here we go, 37.01 over 8 plus 8.4. Now this is a great problem because it shows us what we have to do. It's all about lining up that dot. You got to line up the dots. And we don't have anything here. I'm going to add a 0 just so we have something in that value. And then we just add like a normal addition problem. 1 plus 0 is 1. 0 plus 4 is 4. Don't forget to bring the dot down again. 7 plus 8 is 15. Carry the 1. And 1 plus 3 is 4. So we get 45.41. All right. Just waiting for this to load once again. There we go. There we go. Let's get to the next problem. There's a math teacher somewhere. I can't remember his name, but he wrote a song called, I think it was for division of decimals, but it was called It's All About the Dot. It's all about the dot. And he was again talking about that whole idea of, actually I think it was addition or subtraction of decimals, but it's all about the importance of lining up these numbers by the dots in order to get this, in order to do this operation precisely. So these I'm now just going to do them in my head just to get through these topics and get to the next topic. But yeah, I always think, of course, if you are on my YouTube channel or even some stuff you may have seen on Instagram, you probably know that I think music is such a great way to teach math. I think it gives you something that is not only fun, but something that works as a very powerful mnemonic when you're trying to learn difficult formulas or operations. And I definitely recommend trying to look at all the different resources, music-based, that you can find if that's a way that you like to learn. All right, we're just waiting for this last problem to load here. This becomes 30.45. All right, so we've been streaming now live for about an hour and 16 minutes. Thank you guys who just joined on in my Instagram live stream. So if you want, I'm solving every topic in pre-algebra live, and I'm doing it on my YouTube channel. So if you want to actually follow along and see what I'm doing, I encourage you to go to my YouTube channel, go to YouTube, search for Scalar Learning, and there you can watch the live stream. You can actually see the problems that I'm solving on the screen, whereas otherwise if you're just watching here, you're kind of just listening to me explain the problems, which is a lot more difficult. So I would suggest go to YouTube and check out my live stream there if you're interested in learning pre-algebra. Sweet. Okay, now doing more algebra stuff, which I love. Evaluating an algebraic expression. And again, this is all about plugging and chugging. Really, it's just replacement. We're taking wherever the variables are, they're giving us values for the variables, and we replace those variables with the values. This is pre-algebra is a way to get you familiar with and comfortable with using all sorts of different letters in math operations. And slowly, as you become more comfortable, more familiar, it can get more advanced and it won't feel so overwhelming. So we start off with g plus h over 6. And we're going to replace that g because it says 27. G equals 27. And we're going to replace it with 27. We're going to replace the h with 24. And so now we've got 27 plus 24 divided by 6 is 4. 27 plus 4 is 31. Let's see if that is correct. Still waiting. All right, got it right. Cool. Let's go on to the next problem. Okay, so once again, just waiting for the next problem here. And if you guys have any questions on Instagram or on YouTube, feel free to throw them out there. So we have 5y plus x. I'm going to replace that. It becomes 40. Actually, I'm going to do this one quickly. 45 plus 7 is 52. All right, next problem. Still waiting for it to load. Got one more, and then we can move on. Here we go, m minus 24 over n. And that is just 8 minus 24 divided by 6, which is 4. So 8 minus 4, which is 4. All right, make sure I did that correctly. See if that worked. There we go. Excellent. Continue my, so remarkable. That's awesome. And now what is that? A learning streak of 2 topics. That seems strange because we've done, I think now we're somewhere around like 30 some topics that have been solved today. Maybe 35. But yeah, we'll check that progress. Actually, we can quickly check it right now. Somebody on Instagram is asking me why I like math. I'll answer that since we have to wait so long anyways for this program to load. I'll answer that right now. There's a lot of reasons, actually. Yeah, many, many reasons. If I had to succinctly state why I like math, I just find it fun. The problem-solving process and coming to an answer and then knowing that answer is right and doing it following a certain number of steps and the logic element added in there, I don't know. I just find it enjoyable. And I don't know why some people naturally, or not naturally, but why some people develop that pleasure level for math and some maybe don't, or don't do it maybe right away. It's a question I'm constantly trying to figure out because I think that lies at the heart of really good math education and really being able to inspire students and people to enjoy math the same way I do. And then you can become very comfortable with it, and then you can actually use it to your advantage in whatever it is you do. I'm just going to make sure we got some. Oh, so somebody's asking me, I should make the problem bigger. That's a really good suggestion. So I'm so sorry if they're hard to see. I can play around with some different formats, but right now I've kind of got this set up a particular way on my live stream setup. But thank you for that feedback. I will definitely take that into consideration as I do my next live streams. So now let's see. So somebody's asking what percentage I'm at. Let's take a look here. Oops. I go here, right? I got to go to home. So I'm at 34 topics. Whoops. Oh, no. There you go. I'm at 5%. So 5% out of 100%. Making progress. Okay, let's continue back with my pass. So 34 out of 630. Let's keep going. Next question. Man, this is going so slowly. Rounding tens or hundreds. Okay, now we know the topic. So rounding to tens or hundreds, this is all about whatever they're asking us to round to. We look at the digit directly to the right of the digit we're rounding to. So if we're rounding for the hundreds, we look at the 10 spot. If we're rounding for tens, we look at the 1 spot. And that influences which way we're going to round, whether we round up or it keeps the same. All right, let's give it a shot here. Rounding to tens or hundreds. Let's see. All right, there we go. 124, round to the nearest 10. So what we do is we look at this number and we're going to look at the unit spot to decide whether or not we change that to. So the unit spot is less than 5. If it were 5 or greater, it would tell this guy to bump up by 1, but it's not. So we keep this the same, and then this drops off to 0. And we got 120, and that's to the nearest 10. And why we do this for estimation purposes. And what's up, Cannon Cash? Yeah, good morning. We do this for estimation purposes to get nice round whole numbers that are easier to work with. Let's go on to the next question. I was just talking about rounding with somebody last night, actually, and the benefits of it and the value of it in terms of estimations. Being able to make quick calculations in your head on the fly. It's really important for people who go into jobs like management consulting, or I could see even investment banking to a certain extent. But when you get interviewed for these big consulting jobs, consulting firms, they'll often ask, they want to see how fast you can do quick mental calculations. So being good at math is really important for their hiring process. 71 to the nearest 10, that's just 70. And if you think about it on a number line, we look at 71, here's 70, and here's 80. So the nearest 10 is either 70 or 80. It's definitely way closer to 70, and that's why we round there. All right. Oh, EJ, what's up? It's Ella. Okay, cool. I was wondering. Let's go on to the next one, if this will load. This is taking so long. I gotta think there's something up with their servers today because it's a day off and it's the day before we're gonna start school again. I really don't know what's going on. Rounding to tens or hundreds. All right, here we go. More practice. What just happened? Oh, did I accidentally click? Oh, shoot. That's weird. So somehow I think I accidentally clicked explanation or something. And I didn't mean to. But it gave the explanation instead of allowing me to answer that question. So now I got to do two more. I got to answer two more questions instead of simply one. It's a bummer. See, now I get to see, I feel that frustration that I think my students often feel when they do something on accident like that. So this is quite interesting. All right, so to the nearest 100, again, 517. This is less than 5, so we just keep it at 500. Okay, come on, come on. Cool. Let's get to that next one. Next problem. I'm really looking forward to when we start getting into some more algebraic concepts. I think that'll be a lot more interesting than these whole number and integers problems. Now that's the thing with ALEKS, you have the flexibility and the option to jump around. You don't have to do it exactly the way I'm doing it in this linear progression, which is what makes it really nice. It's a flexible curriculum. But the purpose of doing this topic first is this, again, lays the foundation for everything else you'll need in algebra, geometry, calculus, anything you'll have to do. So there is a rationale to do it this way, but you don't have to. I think that's one part of ALEKS that is good, is that because of that flexibility, it has a greater likelihood of feeling more engaging to students as they're using it, because then they maybe do a bunch of algebra problems, they get a little tired of that, want to do some geometry. You get to mix it up and have variety that is not necessarily determined by a teacher or a third party. It's determined by them. So hey, what's up? So you're asking, what am I sharing? I'm going through the Pre-Algebra ALEKS Pi on my YouTube channel. If you want to see what I'm doing, go to YouTube and search for Scalar Learning. That's my YouTube channel, and you can check everything out there. All right. Whole number division, 3-digit by 2-digit. Here we go. 162 divided by 18. Now this is 18. You basically, long division is not even really going to help here because 18 doesn't go into 16. It only goes into 162. So we have to think, we have to sort of guesstimate. And we know that 10 times 18 is 180. So maybe 9 times 18 will give us 162. And let's try it over here. Let's do the multiplication problem. 9 times 8 is 72. Carry the 7. 9 times 1 is 9. Plus 7 is 16. And that's it exactly. So 9 times 18 is 162. Remainder 0. All right. You know what? Another thing you can do with these division problems, if you wanted a shortcut, you can almost reduce what we're doing. Like you can reduce 162 and divided by 18 by dividing both of these numbers by 2 first. So you could have been like, oh, well, 162 is actually 81 when you divide it by 2. 18 divided by 2 is 9. And that's perhaps an easier division problem. Because again, you want to think about a division problem as a fraction. It's really 162 over 18. All right, let's do another division problem. All right, 49, 147 divided by, that's just 3. So, hey, what's up? So I see you're asking a question about what I'm doing. I'm basically going through a pre-algebra pi in a program called ALEKS, and I'm solving all the different problems that I can today in a live stream on my YouTube channel. So if you want to see what I'm actually doing, go to my YouTube channel and search for Scalar Learning, and you'll be able to jump onto the live stream there. And then you can actually see my screen, and you can see the problems I'm solving and what I'm writing. All right, so hopefully that answers your question. All right. All right, and this will just be 5. I'm gonna need more coffee. Hey, what's up? You're from Turkey. I know Turkish. Merhaba. Nasılsın? All right, let's continue the path here. Remarkable. It's very, very cool. Where are we at? Where are we at? Yeah, is my Turkish good? I remember little bits and pieces of Turkish because I lived there. I lived in Istanbul for a summer for 3 months in 2001, and then I went back a few times. So what else do I remember? I remember efendim. Yeah, I can't remember. Çok seviyor, right? Means I like a lot. All right, word problems on unit rates. Let's see what this topic is. Man, this loading time is killing me. I was really hoping to try and knock out a lot of the pie today, but I think this loading time is going to be the end of that goal. Word problems on unit rates associated with ratios of whole numbers. Gina reads 64 chapters of a book in 8 hours. What is her rate in chapters per hour? What I always say is when we're asking about rates and we're saying per something, we always divide by what comes after the per. So here we do chapters per hour, means we do 64 divided by 8, which is 8. So 8 chapters per hour. Let's see if it's right. Come on. Yes. Got it. All right, cool. Yeah, I do want to come again, actually. Where do you live in Turkey? Yes, I can speak a little bit of Turkish. Türkçe biliyor. And I can, what other words? Yeah, I remember I love you, seni seviyorum. Oh, cool. All right, water comes out of a pipe, 10 gallons per minute. How many gallons come out after 5 minutes? This is it. So if it's 10 gallons per minute, 20 gallons after 2 minutes, 30 gallons after 3 minutes, after 5 minutes, it's going to be 5 times 10, which is 50. Güzel. I remember güzel. I remember that word. When I was in Istanbul, I was staying in the Asian side near, what was that street? Bada Caddesi? So that's where I was. All right, come on, come on. Here we go. If you've been watching since the early morning, you may notice it's starting to get a little lighter in here as the sun is rising. As I started when it was darker, way early in the morning. Okay, 7 minutes. Chang can type 28 words. What is his rate in words per minute? Okay, so again, per minute, we're dividing 28 by 7, which is 4. All right. I wasn't on, when I stayed in Bada, I didn't stay on Bada Caddesi. I can't even remember now, but I was close to it. But that was actually not my place. That was, I was 21 at the time. But that was where my girlfriend in Turkey was staying. So we were very close to Bada Caddesi. All right, on to the next topic. This thing needs to load way, way faster. That is my major feedback. In fact, I actually interviewed Alex on my podcast about a year ago or a year and a half ago. I interviewed one of the representatives, and he was great. It's a, like I said, it's a dynamic, wonderful program. It's evolving. It's owned by McGraw-Hill Education, and I think it's the best. If you're looking for a self-contained, self-paced, good math curriculum. My name is Huzefa. Huzefa. All right, multiples. And now we're talking about multiples of different numbers. I wonder if this is going to be about least common multiples. But let's see. I'm not sure. Multiples of 2. So the next 3 multiples of 2, we're talking about 14 is a multiple of 2. The next one would be, now it's almost like we're adding by 2s. The next would be 16, next would be 18, and next would be 20. All right. Yeah, my name, I know that my name can be found in Turkey. It is, I believe it's an Arabic name, Arabic origins, which is why. All right, here we go. And hopefully you guys, were you guys able to find my YouTube channel? Come on, Alex, load. Here we go. Multiples of 5. So again, it's just like we're adding by 5s, right? So we got next would be 35, next would be 40, and next would be 45. Is it right? Is it right? All right, cool. Awesome. Yeah, and hopefully you will enjoy this. This live stream is about to end in about a minute because I think Instagram has a particular limit, much shorter than YouTube. So when this ends, I'm going to go offline here, but you guys again jump onto my YouTube live stream and you can follow along there. And it will be better for you anyway, so you can actually see what I'm doing. I have 1 minute remaining on this live stream for Instagram. YouTube, we're going to keep going as long as I can. All right, introduction to finding equivalent fractions. Here we go. Come on. Here we go. Equivalent fractions. And I'm going to show you, this looks like a pretty good explanation up here, but I'm going to show you in real time once I get on there. All right, 8 seconds, guys. So I'm about to jump off of Instagram, but come on YouTube, go to YouTube, search for Scalar Learning. I'll see you guys there. Peace. Here we go. So 1/8 is equivalent to what over 16? You think about it. How do we get from 8 to 16? We multiplied by 2. Don't think of addition. We always want to think of multiplication with equivalent fractions. So we must do the same on top. Must be a balance. So we multiply that 1 by 2, and we get 2/16. That is the equivalent fraction. Hey, what's up, Merv? I see you jumped on to the live stream. Thank you so much for joining. Yes, I agree. This is much better. So I'm going to do my best to keep clicking back and checking my messages, but I can, the only downside of the YouTube live stream is I can't see the messages when I have the ALEKS window open. All right, let's go to the next problem here. Man, this is just taking way too long. To all my students who are out there watching this, I feel your pain when you're feeling like the program is glitching. All right, so again, same thing, multiply 3 by 5 to get to 15. So we multiply the 2 by 5 and get to 10. Come on. Yes, it's right. All right, let's keep going. Now, it's interesting. In our class at the school where I teach, we have a goal to do about 16 topics every week. And to put that in perspective, I have just done, well, I'll show you in a second. Okay, so again, multiply the 4 times 3. So 1 times 3 is, that's 3/12. Okay, and after this topic, I'll check. And so that's what we asked them to do. And that's over the span of a week, right? So we estimate that it takes around 1.5 to 3 hours, depending on the student, to complete 16 topics. And so let's go to, I'm going to check my status in a second once this actually processes and loads. The one thing I can say is when you're doing that much, I can understand that these little technical glitches can perhaps be frustrating. Okay, so I'm going to return to home page quickly and check where we're at. So we're at 6% here total. So 39 topics, so nearly 40 topics. So this would be the equivalent of, what is it, about 2 weeks worth of math that we've done in the last hour and 45 minutes during this live stream. But again, I'm obviously going to be way faster because I know all the material and I'm doing it in a much quicker way. For students where they're encountering material that they haven't seen for the first time, that's obviously way more difficult and more time consuming, more likely to make mistakes, etc. So that's why it's a much longer period usually. I came prepared today because I knew this live stream was going to go quite a while. So I got some water, I got some coffee, got everything set up, trying to sit comfortably so I can last, well, as long as possible. Wait, the Web Paint app I can draw on ALEKS? Okay, I'll have to look into that another time. Oh, and then I can just basically have one window open. Is that what you're saying, Ella? All right, well, I'll come back to that. We will talk about that on Monday. Ella, who is watching on the live stream right now, is one of my students, so that's really cool. She's giving me suggestions. All right, decimal addition with 2 numbers. All right, still waiting for this to load. Come on. It takes 2 seconds. All right. I will definitely check it out. The only thing is for today, I just want to keep the format consistent with what I've already been doing. But hopefully you can show me that tomorrow at school. Okay, so again, when we handle a problem like this, we're going to be tackling a decimal addition problem. Remember, once again, it's all about the dot. You got to line that dot up with these numbers and then carry out the multiplication. If it's helpful for you, put a 0 here if you want something in this space as well. And then let's just add. The 0 plus 6 is 6. 3 plus 9 is 12. Carry the 1. But again, bring that dot down as well. 1 plus 8 is 9, and we get 9.26. Right, the only mistakes, the most common mistakes with these type of problems when people get them wrong is they just don't line things up carefully. You know, if you have bad handwriting or it's not all nice and neat, then it can be a big disaster. So you want to make sure you're working with great attention to detail when you're setting up these problems. You do so meticulously and you'll see your rate of errors drop very, very substantially. Oh, cool. Yeah, awesome. So I'm glad you guys are watching. I'm looking forward to getting to the more complex topics, more difficult topics, so that'll probably be later in the day, much later in the day. So if we can see, you can kind of see that it's taken about 2 hours to do 40 topics. So if we extrapolate that out, at the 8-hour mark, hopefully I'll be around 160 topics in. But that's a far cry from the full 630. So this is going to be a very lengthy process. Okay, so 7.43 times 56.4. I'm lining up that dot. Add a 0 just to make it look nicer. 3 plus 0 is 3. 4 plus 4 is 8. 7 plus 6 is 13. Carry the 1 and 6. 63.83. Come on. This is crazy. This needs to go much faster. Ella, if you're watching right now, I want to ask you, when you guys work on ALEKS in class, does it take usually this long to process and go to the next topic, or is this abnormal? All right, so let's line this up. 15.52 plus 3.7, and we're adding a 0 there. 2 plus 0 is 2. 5 plus 7 is 12. Carry the 1. Bring down the dot. 1, 5, 3 is 9. Bring down the 1. 19.22. Come on, is it right? What's happening? Yes, all right, 3 in a row, boom. On to the next topic, a learning streak of 8 topics. Okay. All right, Merv, see you later. Thank you so much for joining. I hope you found that helpful. And before you go, make sure to check out the other stuff on my channel. I've got other cool resources related to math, and I've also got math music videos, which are fun. Even if you're not a big fan of math, I think those are pretty enjoyable regardless. So check that out, and thank you so much. Okay, let's keep going on the path. Okay, once again, introduction to finding equivalent fractions, which I think we did a topic similar to this not too long ago. All right, same idea, yeah. Okay, so now this is kind of the reverse of what we did before. Come on, we need this to load faster. Okay, here we go. 5 over 10 equals what over 2? So we think, how do we get to 2, right? Well, we're obviously not multiplying. In this case, we're dividing by 5. So we got to do the same thing here. We got to divide the numerator by 5 as well. 5 divided by 5 is 1. And so the equivalent fraction is 1/2. All right, cool. Next. Almost at the 2-hour mark. We're getting close. Now, if we weren't having these huge lags, I think I would probably have gotten through maybe an additional 10 topics, maybe 20 topics. This lag is definitely slowing things down. All right, here we go. So 10 over 16 equals what over 8? Equals blank over 8. All right, so let's see. We're going to go from 16 to 8, and we're going from 10 to what? So how do we go from 16 to 8? We divide by 2. 10 to this, we must divide by 2. So 10 divided by 2 is 5. Oops. Come on. All right, excellent, excellent. Let's move on. Introduction to finding fraction equivalence. We got one more problem. Just waiting for this thing to load. All right, 3 over 12. 3 over 12 equals blank over 4. Divide this by 3, divide this by 3, and we get 1. There we go. All right, let's continue. Whoops, continue the path. We're almost at the 2-hour mark for the live stream. This is the longest live stream I've ever done. I think the longest I did before is maybe an hour and a half, something like that. So this is kind of cool for me from that respect. All right, we're going back to these multiples problems. There we go. Finally loading. So again, it's the same idea. 9, 18, 27, 36. So we're doing multiples of 9 or any number. We're just adding by that number. That's literally what a multiple is. It's it's all the, multiples of 3 are 3, 6, 9, 12. So to get to each subsequent one, I'm adding that 3 value over and over. Okay, the next multiples of 8. So we're just adding by 8. So then we'd have 48. 8 plus 48 is 56. 56 plus 8 is 64. And that's it. That's all there is to it. 48, 56, and 64. All right, come on, load. Yeah, I'm really, I'm really confused as to why this is loading so slowly. I know that Ella's given me a suggestion, but I have to think that this is server related. I don't know why, because it's ALEKS that's processing this so slowly. And my computer is fine, even though I have all this stuff open. I don't know what's going on. That's why I just tend to think that maybe their servers are being overloaded today. It's just a guess. But yeah, this is really frustrating. All right, here we go. Multiples of 7, add by 7. It's 35, 42, and 49. Yeah, because you know what? I've definitely usually seen when I see my students do this, it goes way more quickly. There we go. Correct. Last one. Now, another great program to use, of course, for online math curriculum is IXL. IXL is great too. I think ALEKS is superior because it lays out this sort of cumulative path, and it has that nice target of the pi. It's got a lot of little details that I think makes it simpler and also a little bit more interesting for students as they follow along and check off their goals. Everything is very organized. As far as the metrics for teachers administering the program, it's fantastic. You can see how many hours your students spent each week, how many topics they've mastered, how many topics they had to relearn. So it's a lot of very important and useful data that you can use to modify and adjust the curriculum as need be when you're going along. Yeah, Ella, can you check your ALEKS and see if it's doing the same thing for you, please? All righty. Getting to the next one. Additive property of equality with whole numbers. Come on, you can do it. Load ALEKS. It's funny, a lot of students, when they're first learning about ALEKS and they search for it, they spell it, of course, ALEX, and then they have no idea where it is, but it's ALEKS. Come on. Oh boy. Here we go. Solve for v. So v plus 1 equals 5. So what v would have to be what to make this sentence true? Well, in this case, we're starting to get introduced to variable isolation. Really, v has to be 4. If you're not sure if that's the case, you can always subtract 1 from both sides. You can basically take this 1 away. But you have to do it to both sides to make this accurate. So 1 minus 1 is just 0, and then 5 minus 1 is actually 4. So v, in fact, has to be 4. There we go. Correct, correct. Let's go to the next one. Oh my, my, my. This is just too much of a delay. All right, Ella, if you're still watching and you're still on, please check to see if your ALEKS is going this slow. I need to figure out what to do here. Is 10 correct? All right, let's see what happens here. Awesome. I think the number one thing you hear as a math teacher, math tutor, maybe even as a parent of a student who's in math is the question, why do I need to learn math? What's the point? When am I ever going to use this or that? And I think those questions pop up more and more as kids start going through, students start going through more advanced curriculums, because it becomes, or it feels like it becomes more abstract. And what's the, when am I going to need to know how to take a derivative in the real world, etc. And I'm always trying to answer that question because it's a question worth asking. I don't think it's a question that teachers or parents should shy away from. What is the relevance? Why are we learning anything that we learn? It should always be asked, and I think it's great to ask that. I'm currently in the process of trying to write a book about, to try and distill that question down into all the different various applications of each precise mathematical tool that we learn throughout middle school, high school, everywhere. And I mean, the applications are really innumerable, but to try and condense it down into something that makes sense, I think it'll be valuable for students and parents. And then also just beyond the actual specific applications, I think that another big tangible piece of the value in math education is the logic skills that are developed, the problem-solving skills. And so those are, again, not directly tied to mathematic understanding, but it certainly that is a skill that will be used forever and ever. It's kind of like the equivalent of working as an attorney and learning to be a really terrific writer. And yeah, you maybe if you go on and do something else, you don't necessarily need that understanding of legalese, but the writing piece you'll take with you forever. Come on, buddy. Here we go. Plotting number lines. So we're gonna plot 7 in the opposite of 7, which is -7 in these examples. So we're going to do this together. Come on, please load. There we go. -1 and the opposite of -1. So -1 is right here. When they say the opposite of -1, it's just 1. We flip the sign. The other way to think about it is this is going to form 2 symmetric points around 0. So we know that our other point has got to be right there. That's a cool way to understand opposites. Opposite numbers are the same distance away from 0, but just going in different directions. All right, plotting opposite integers on a number line. Here we go, 8 and 8, -8. Boom. Whoops. This is not going fast enough. This is really ridiculous. Does anybody have any questions who is watching on YouTube? Make sure to post them in the chat box and I will answer them. And if you're joining now, again, we're doing a live stream. We're going through the entire pre-algebra curriculum. It's a little bit stifling because the servers, I think at ALEKS or McGraw-Hill, seem to be really lagging. So we're waiting a long time in between each question. It was going much more quickly in the morning, but now it's going very slowly. So it's just something we're going to have to deal with throughout this live stream. The plan was to try and there's 600 and some topics that I'm trying to get through. It's looking like there's no way that's going to happen today, especially because I have to start teaching around 4:30. So that's my cutoff time. Or maybe 3:30 will be my cutoff, and again too, we'll see my endurance levels. I've never done a live stream for that long before, so this is a new experience. I don't know how I'm gonna hold up in another 2 hours, 3 hours, 4 hours, but I'm gonna do my best to keep it going all the way until around 3 o'clock. All right, another topic done. That's 12 topic learning streak. I think those learning streaks are basically when you don't make any mistakes. And then here and there, I think I've made a couple mistakes throughout the day that have set me back. But I had a really long streak initially. Come on. Simplifying a fraction. All right, let's see how this goes. This is so crazy. I'm still keep checking back to see if my student Ella has experimented on her ALEKS. So she hasn't written back yet. So I'm waiting to see because I'm just curious to know why is this going so slowly. What is up? I've never seen it go. Maybe I have actually certain times for my students where they're having lags, but this seems really, really crazy. All right, simplifying a fraction. Come on. You can do it, buddy. Let's at least get something set up over here. All right, come on. Come on. There we go. 5 over 45 in the simplest terms. Okay, we got 5 over 45 and put it in simplest terms. Basically, we're looking for the greatest common factor of these two numbers, 5 and 45. It's actually going to be 5. Both of these can be divisible, divided by 5. So I divide them both by 5, and we get 5 divided by 5 is 1, 45 divided by 5 is 9, and our answer is 1 over 9. Come on. Now, I don't know if you guys noticed my shirt here, but this is the logo for the channel. There we go. Awesome. 1/9. Perfect. Come on, simplifying a fraction. What's happening? All right, there we go. 27 over 36. I'm going to divide them both by 9, and we get 3 over 4. Ella has not responded yet. Still waiting to hear back. But simplifying fractions, that's really what it is all it's about. So you think about it, the way I did that 27 over 36 was I figured, well, I kind of noticed that they're both divisible by 9. Now, the beauty of it is if you didn't catch that and you're like, well, at least they're both divisible by 3. You can do this step by step. 27 divided by 3 is 9. 36 divided by 3 is 12. And then you can check it again and be like, oh, wait a minute. These are still both divisible by 3. And now we get down to 3/4. So the whole emphasis on GCF, or greatest common factor, it's not actually that critical that you find the GCF right off the bat. You can always do this piecemeal. And that's the beauty of it. Whatever approach works for you is going to work. It's just going to work. It is what it is. But GCF, if it comes to you, if you know what the GCF is, obviously that is going to be the fastest way to do it. All right, one more problem and we're done with simplifying a fraction. I forgot to write down how many problems are in this pie slice because I think we're still, oh no, we may not be actually in the, yeah, we're not in that same topic that we started with. So it's jumping us around. The other cool thing about ALEKS is there's certain topics that are restricted. You don't have complete free reign because it essentially makes certain topics prereqs for other topics. And I think that's really important because it ensures that you're always going to have enough skills to tackle whatever topic you want to try. Okay, so we're dividing the top and bottom by 4, and we get 2/5. That should be right. Come on, 2/5. Let's see what happens. All right, sweet. There we go. There we go. Keep at it. Next topic. Let's go pi. Yeah, so if anybody else out there is a user of ALEKS and you guys are watching and you guys want to throw up on the board anything that you've dealt with in that program that you think could be improved or what you like, I'd love to hear it. I'd love to get more feedback, and I can always share the feedback directly with my contact at the company who I interviewed a year and a half ago, and I know they're always looking to make their product better and better. Coffee is almost done. Let's go. All right, subtraction of aligned decimals. So again, this is more of the same. We've kind of already done this. We did this with addition. We did subtraction. You see how it's stepping up in complexity. So the other problems were easier. Now look how dense, look how long and big these numbers are. So now it's upping the ante in terms of it's that same skill that we've already developed and already learned to a certain degree. Now we're refining it and honing it and repeating. And again, that's why I think it's great. Some people have argued that they feel as though the amount of practice required by the program is not enough. You need to do more practice problems. But what I remind them is, and maybe that's true to a certain degree for certain people, but what I remind them is you're seeing me do answering 3 questions and then moving on to a new topic. That's only because I'm getting 3 in a row correct. When you're making mistakes and you're getting things incorrect or you're asking for the explanations, you have to do more. In some cases, you may have to solve 8 or 10 problems before you finally get it. But all right, 79.11 minus 63.8. And I added a 0 here just so everything lines up. And now we're just going to subtract down. 1 minus 0 is 1. We can't do 1 minus 8. We borrow from the 9. That turns into an 8. That becomes 11. 11 minus 8 is 3. Drop the dot. 8 minus 3 is 5. 7 minus 6 is 1. And we got 15.31. Oops. Okay, let's move on to the next one. But yeah, it's important to recognize that, and I think when you approach it there, and then also once you pass the topic, you're not done. It's revisited in a knowledge check, which you may or may not see today. And truthfully, I actually don't want to show myself doing the knowledge check online because these are more topic explanations. This isn't meant to be an explanation for those knowledge checks. And the knowledge checks is really important that we have a rule at our school, for example. We don't help students on knowledge checks. They're meant to take that portion independently to really make sure that they've learned and understood each operation. And if they don't, if they miss a topic, then they have to redo that topic. But that's good. The topic doesn't take too long. Once they've already gone through it, it just serves as a refresher. All right, so again, subtraction of aligned decimals. And let's see when this thing comes back, what's going on. All right, 99.19, so I'm just going to do this in my head. That is 0.8, 0.9, 90.91. So 90.91. You know what? I'm going to write it out. That's kind of hard. 8.28. And let's subtract. It's 1, 8, 11 is 9, 0, and 9. So I think that's correct. 90.91. I think that's going to be it. Come on. But you see, it's also important as we do problems like this to make sure to rely on your gut check. And I could tell that number was going to be around 91. And if I got close to 91, I had a pretty good chance of it being correct. So you need to do those gut checks. In fact, that's why good number sense is so important, even if you go on to other forms of math or economics or things like that, where you're going to be using calculators and software and all these things. The benefit of having good number sense is that if you happen to type something in incorrectly or you analyze the data improperly, you're always thinking to yourself, wait, does this roughly make sense with my results? Is this along the lines of what I should have expected to get? And those gut checks are really important. On my podcast, I interviewed an economist named, and he's also he works on all sorts of data analytics, and he talked specifically about that, where yeah, they use calculators and software all the time to make these big calculations, but he uses the gut checks on a routine basis to make sure that he's doing everything correctly. Come on, 60.59. All right, moving on to the next one. Continue my path. This is very frustrating. Let's see here. You know what I think I'm going to do, because this is just crazy. I think what I'm going to do is I'm going to take a break and then I'll jump back on later. Let me try and restart the computer. Let me see if that has any effect. So I'm going to take a pause and I will be back. We're going to stop the stream and let's resume in a little bit. All right. So this next topic came up. You know what? Let's just quickly knock this out and then I'll take a break. All right, decimal addition with 3 numbers. All right, this is again all about the dot. 6.35 plus 1.5 plus 9.47. So you see how everything is nicely lined up. Now we add it up. Put a 0 there for comfort. 5 plus 0 plus 7 is 12. Carry the 1. 1 plus 3 is 4. Plus 5 is 9. Plus 4 is 13. Dot. Carry the 1. 1 plus 6 is 7. Plus 1 is 8. Plus 9 is 17. So we got 17.32. $17.32 is waiting. Isn't it so suspenseful? Yes, we got it. All right, let's do the next two quickly and then we'll take a break. All right, next one here. Come on, come on. Decimal addition, 3 numbers. Let's go. All right, here we go. 3.4, 6.15, 9.96. And let's add them up. 0 plus 5, 6, 11, 1, 5, 6, 9, 15. Carry the 1. 10 and 19, 19.51. Come on, come on. Decimal addition with 3 numbers. Let's see what's going down here. One more problem. I really hope I can resolve or figure out why this is going so slowly. Maybe we can, when we come back later, it'll be much better. Okay, last one. 2.1, 6.36. 9.95, and we're going to add them all up. We got 11, carry the 1, 4, 5, 14, carry the 1, 1, 2, 3, 9, 18, 18.41. Boom. Come on. Let's see if we can get this to go through. 18.41. All right, guys, I'm so sorry about this. This is just a crazy delay. Okay, excellent. So we've got this topic done. What's up, Merv? You're back on. And yeah, you can see that, yes, I'm still here, but I am about to take a break because it's really just the way that ALEKS is lagging right now. It's just so slow and so painful. So I'm going to take a break. I'm going to come back on a little bit later today. We're going to pick it up and I'm going to see if that resolves the issue. I'm going to try and restart my computer. I don't think it's on my end. I'm pretty sure it's their servers, but I'm going to try it out and we'll see what happens. So if you guys are still around today and want to keep following along with this journey, you definitely can. So in the last 2.5 hours that we've been live, we have completed 47 topics, which is pretty cool, but a long way to go. All right. And that is it for now. I will see you guys next time or shortly thereafter, a little bit later today. See you guys then. Take it easy.